Let's look at 2022 AMC 10A problem 23. Isosceles trapezoid ABCD has parallel sides AD and BC, with BC less than AD and AB equals CD. There is a point P in the plane such that PA equals 1, PB equals 2, PC equals 3, and PD equals 4. What is BC over AD? So let's first draw a diagram or a graph, whatever it is called. Because for any geometry problem, even if it is problem 23 and you don't think you can do it, let's just first visualize what this problem looks like. So we have an isosceles trapezoid with parallel sides AD and BC. And BC is less than AD. So let's say that this is BC. And this is AD, right? So then AB and CD are equal, these sides are parallel. There is a point P in the plane, so it can be outside of this trapezoid, such that PA equals 1, PB equals 2, PC equals 3, and PD equals 4. What is BC over AD? So let's say this point P was here, right? PA is 1, PB is 2, PC is 3. Okay, that's kind of inaccurate and stuff. PD is 4. So what do we do then? What's BC over AD? Right? How does this even correlate, right, with our answer here? Well, one thing we can do here when we're actually stuck, and since it's a problem 23 you probably have to use some really complicated or hard to understand theorem. You have to change the theorem around to make it fit this problem, because if it was just using a theorem, it wouldn't be a 23, because all you have to do is memorize a new theorem, right? Well, we can change the question as per a section in AOPS Introduction to Geometry. You can change the question because this question doesn't specify the height of this isosceles trapezoid ABCD. It doesn't say that the height has to be greater than 0. It doesn't say that AD and BC can't overlap, stuff like that. It's just an isosceles trapezoid, so these two sides are parallel and these two sides are equal. So technically then, technically saying, a straight line with ABCD on them would fit this. So let's draw a straight line. Let's say this is A, this is D, right? And since this quotation marks trapezoid with the height being 0 is isosceles, A, B, and C have to be equal, so they're equidistant, here. This is technically what we want. It is these two sides, BC and AD, are going in the same direction, right? So they kind of are technically parallel, even though they overlap each other. And it is isosceles because AB and CD are equal. So where is P? That's the big question here, right? Where is P? Alright, so PA is 1. And PD is 4. Well, after some thinking, literally, it's pretty intuitive. There's no really complicated thought process here. No, just try to make this work for this, right? And try to find where P is. P is gonna be here. And PA is 1, PB is 2, PC is 3, PD is 4. That's really simple. That's the most straightforward thing you have here, and you can easily think of with 5 minutes or maybe 30 seconds or 10 seconds. But that is what our supposedly trapezoid looks like. So what is BC over AD then? Well, for this trapezoid-ish thing to work, the straight line basically, BC has to be 1, and AD is 3, which is 1 plus 1 plus 1. So BC over AD is 1 over 3, which is B. So it's in our option choices, so we're probably right.